least common multiple, we have to know what multiple means. The multiples of 5 are 5, 10, 15, 20, anything that is an answer when you multiply by another whole number. All of the answers that you get. Basically, it's your 5 times table forever are your multiples of 5. So multiples are numbers that get bigger than what you started with. The smallest multiple of 18 is 18. The next smallest one is 36. And so again, we want one that's in common, but this time we want the least common multiple because our numbers are getting bigger. So we could do the long option. We'll start with the long option again. Start with 18. The next multiple of 18, if you did 18 times 2, you would get 36. If you added 18 again, you would get 54. Those are the first 3 multiples of 18. When I look at the multiples of 30, what's 30 times 2? 60. What's the third multiple of 30? Basically, you see that you're adding 30 each time. And when you're doing the least common multiple, you're sort of going to flip-flop. If you're using the long strategy, you're going to flip-flop between the green one and the blue one. Because I got up to 90, which I passed the green one, so the green one needs to catch up. So I need to add 18 again. You see that you would get 72. Add 18 again, and you get 90. Look at that. We use LCM as a short form for least common multiple. We get our least common multiple. What's the dangers of this method? If you make an adding mistake early on, you could go on for hundreds and hundreds of numbers and never find one. That would not be very much fun. Okay? So, a small mental math error, and then this keeps going higher and higher and higher. So method 2, if we find the prime factorization of 18 and the prime factorization of 30, so we'll start with 18. What are 2 numbers that multiply to give me 18? 6 and 3. You could use 9 and 2 as well. Can you break up any of those any further? 6 and 3. I wrote 6 and 2. So oh yeah, that's not, thank you. I said 6 and 3. And wrote 6 and 2. And then the 6 you could break up to be 3 times 2. And there's our prime factorization. 3 times 2 times 3. Doesn't matter the order. Now in blue, I'm going to write 30. 2 numbers that multiply to 30. 3 and 10. Can you break up any of those? You can break up the 10 to be 5 and 2. There is the prime factorization of now for the least common multiple, the least common multiple needs all the factors. So do we have a 2? Yes. So our least common multiple will need a 2. Does any of them have more than 1 2? No. So we've used up the 2. I'm going to just put a line through it. We used up the 2. Do we have a 3? Yes. Does anyone have more than 1 3? Yes. So when I use that first 3, that use up a 3, the first 3 from each of them. But now there's another 3. I have to use that up as well. Any other numbers that we haven't done yet? There's a 5. So you have to use that as well. So we have to use up all the factors. And if one of them has a factor more than once, we have to use all of those ones to use them all up. If I do, okay, mental math. If you do 2 times 3, you get 6. 6 times 3, you get 18. And then you're screwed because you don't know your 18 times table, so you can't do this question. Well, you can do 18 times 5 and take a little bit of time, and you'll get 90. Okay? But I wouldn't recommend that. It's good math. I should recommend it, because if you do 18 times 5 and know how to do that, that's really good. But in math, the people that are the quickest at math actually do easier math than the people that are slower. And if you can do easier math, why not? What does that equal in the green if I multiply those? 10. And what's left? 9. What's 10 times 9? 90. Is that a lot easier than 18 times 5? Yeah. I love it if you knew 18 times 5. That's great. And you should develop strategies. But if you can do it quicker, perfect. A square patio is built using patio stones that measure 24 inches by 36 inches. These are big stones. If you drew them, can you imagine how big these are? Can you pick one up in your mind and hold it, flex your muscles? You had a stone that big, a paver. Can you see it on the floor here? Each of these squares on the floor are 1 foot by 1 foot. Can you see this is 2 feet this way by 3 feet this way? That's pretty big. You might even need 2 people to carry these. Oh, but your patio is going to look really, really nice. Thank you. And your project is just on that desk there. Okay? Now, you want to build a patio that's a perfect square. If you only used 1 block, would it be a perfect square? No. Okay? What happens, I'm going to cheat and use a rectangle button. And then I'm going to clone it. So this is 24 inches, and this is 36 inches. If I took another square and put it right here, and put it tight to it, do I make a perfect square now? Okay? That adds 24 to this side, which makes that side now 48. And this side is only 36. So I'm like, oh, this is too long now, right? You see that I need to add some more here. Put one there. Is it a perfect square now? Well, I added on the side here. Now this side is 36, making 72. And the other side is 48. Well, we can find out how good to scale I drew. Oh my goodness. So I'm going to have to add here, and add here. And now I add another 24 there. How long is this side now? 72. How long is this side? 72. Did I draw it to scale to begin with? Absolutely not. I failed. Because that does not look like a square. But based on our numbers, it is. Okay? Do you see that this is a least common multiple question? That every time I'm adding here, I'm doing the multiples of 24. And every time I added there, I did the multiples of 36. And I got 72. So sometimes this is going to happen in a word problem. I'll grab it right here. Thank you. Sometimes this is going to happen in a word problem where you start sketching and drawing the picture of what's happening, and then you realize, hey, wait a minute, this is just a least common multiples question. We didn't have to draw very many to get the answer. So actually method 1 of just listing the multiples was not bad. So the answer to this, what is the side length of the smallest square patio? 72 inches, which is just a 6 foot by 6 foot patio. That's not very big. We put like one little table on there, maybe 2 chairs. And sit outside and enjoy the weather until it gets too cold. But can you see in this question, if I gave you, I'm trying to be extra nasty in my numbers. If I gave you 19 and 37, pretty close to this, and you started drawing it out, the smallest square then would be 703 inches. And that I don't think would be very fun with method 1. How many times do you have to add 17s down to get to 703? 37 times. That'd be super long. I mean, not 17, 19. You'd have to write 19, the multiples of 19, you'd have to write 37 of them. The reason I chose 19 and 37, does anyone know why I picked those two numbers? They're both prime numbers. And if the lowest common multiple is just the prime factorization, this is the prime factorization of 19, is 19. The prime factorization of 37 is 37. And the lowest common multiple is just multiplying all your prime factors together that you have. It's just 19 times 37, which happens to be 703. That's way quicker than writing 19, 38, 57. Keep going. 19 times table, that's a tricky one. I had it down pat a while ago, but I don't know. I think I'd struggle a little bit right now with it. So definitions are important because least common multiple and greatest common factor can be easy to mix up. If you know what factor means and you know what multiple means, your life will be easy. So a factor is something that you can divide a number by. So we're looking for something that divides both 180 and 224 as big as possible. Some people like to always divide by 2 to start with. That's perfectly fine. Can you see that 180 is 2 times 90? Okay. Sometimes with prime factorization though, if you can find bigger numbers that multiply, like, can you see that this is 18 times 10? Sometimes that makes it go a little bit faster. What about 18? What do you want to go with? 6 times 3 or 9 times 2? Someone pick one. 9 times 2? Or did you say 6 times 3? I said 9 times 2. Okay. Like, that would be a really jerk thing to do, right? You say, someone pick one, you say 6 times 3, and like, 9 times 2. But he did say 9 times 2. And then 10, there's really not very many options, is there? The only option for 10 is 5 times 2. Can you break up any of these? Absolutely. The 9 is 3 times 3. There's your prime factorization of 180. $224. Sometimes you can't see big numbers that multiply. 224. Probably, I would say most of you would start with a 2 times 112. And then be like, okay, 112 I also don't have in my times table. So I'm going to have it as 2 times 56. Then 56 should be in your times table. Seven times 8. Now sometimes with 8, do you see that 8 is 4 times 2? And then the 4 is going to be 2 times 2? If you wanted to with 8 already go to 2 times 2 times 2, to save you an extra line, that's perfectly fine. So this is the prime factorization of 180, and this is the prime factorization of 224. So then to get the greatest common factor, we need to find the ones that are in common in both of them. Do they have 2's in common? Yes. They have 2 2's in common. Anything else in common? Oh, what disappointing. There's nothing else in common. Do you see that? I'm like, this one has 3. Oh, this one doesn't. This one has a 5. This one doesn't. This one has a 7. That one doesn't. All that work to find out the answer is 4. I was hoping for a bigger number. I was like expecting something bigger than that. 4 seems small, but that is the greatest common factor. One of the things that greatest common factor and least common multiple, the reason they confuse you is because greatest common factor is something smaller than what you started with, which your brain says, wait a minute, it has the word greatest in it. Shouldn't it be bigger? And least common multiple will always be an answer that's bigger than the numbers that you started with, which causes your brain to go, wait a minute, isn't least like supposed to be small? So it messes with your brain a little bit, these definitions. So it's really important to know if you start with the last word, if you start by knowing what is a factor is something that divides something. It has to be smaller. So then when you think of greatest common factor, you're like, I know my answer is going to be smaller based on that. When I get a least or lowest common multiple, if I think of the word multiple first, then I know it has to be bigger. I'm not going to use method 1. I don't want to add by 28. I feel like I'll make a mental math error somewhere. Instead, I'm going to do 28, 7 times 4. I'm okay if you do that all in one step. Do you think you could do that all in one step? As soon as you saw 7 times 4, you're just like, oh, I can break up the 4 to 2 times 2. Okay? I'll do 42 in green. It's 7 times 6, and 6 is 3 times 2. And I'll do 63 in blue, which is 7 times 9, and 9 is 3 times 3, could actually write the prime factorization of those quite quickly. Lowest common multiple. Start with 2's. How many 2's do we need? We need 2 of them. In order to take 2 out of here, that means we use up that 2 as well. How many 3's do we need? We need 2 of them because this one has 2 3's, which uses up that 3 as well. And how many 7's do we need? Just 1. Because they all have 1 7. I don't know if I can see any really easy mental math for this. I might do this first. If I was doing mental math, that's 63. Double that is 126. Double that is 252. So if we use our prime factorization, our life can be easy. All right, there's a homework assignment listed there.